This is the Unit 4 Lesson 3 video. Our lesson this time comes from Chapter 12, Section 3 out of the textbook, and we're talking about trigonometric functions of general angles. We have one mathematical practice just to focus on in this lesson, which is attending to precision. It's really important that we make sure we get the right answers, is basically what that's saying. So we've already found trig function values for acute angles in this unit. And in this lesson, we're going to find values of trig functions for general angles and find values of trig functions by using reference angles. Reference angles are really important. They're going to help you understand this concept a lot easier. So new vocabulary for this lesson is a quadrantal angle and a reference angle. So first we're going to start off with our key concept, the way to find a trig function of a general angle. So since we're dealing with angles that are on an xy plane, our terminal side, the final side of the angle, is considered the radius of a circle. So instead of considering sine as opposite over hypotenuse, you can now consider it as y divided by r using the Pythagorean theorem. The sine is how far you go up or down, and a cosine is how far you go left or right. So cosine is x over r, and then tangent is still the height over the horizontal distance, so y over x. All these ratios are listed on the poster at the front of the class that says trig functions. So you've seen these already, but you probably didn't understand where they came from. So example 1, we're going to evaluate a trig function given a point. So it says the terminal side of angle theta in standard position contains the point 8, negative 15. Find the 6 exact values of the trig functions of theta. So because we're at the point 8, negative 15, we're going to go 8 the positive x side and 15 down in the negative y direction. So what we need to do is sketch the fact that we know the sides of each of these two parts of the triangle, and then use the Pythagorean theorem to find r. When you do that, we're going to get 17 for r. So we have x is 8, y is negative 15, and r is 17. So sine is y over r, which would be negative 15 over 17. Cosine is x over r, which is 8 over 17. Tangent is y over x, which would be negative 15 over 18. And then cosecant, secant, and cotan are just the reciprocals of sine, cosine, and tangent, respectively. All right, check your progress problem. We're going to find the exact values of the 6 trig functions of theta if the terminal side of theta contains the point negative 3, 4. Again, I'm not going to show the answer. Make sure you write this down in your notes as your classwork problem. Pick the answer choice, A, B, C, or D, and make sure you include that in your notes. Okay, next we have another key concept. This is the definition of what a quadrantal angle is. A quadrantal angle has the root in their quadrant. So the quadrantal angles are 0 degrees here, which has the point r comma theta, 90 degrees, which divides the first and the second quadrant, which has the point 0 comma r, 180, which is this, negative r comma theta 0, and 270 degrees, or 3 pi over 2. Each of these, they also show the radian, 0, pi over 2, pi, and 3 pi over 2, and that has a point 0, negative r. So example 2, we're going to look at a quadrantal angle problem. It says the terminal side of theta in standard position contains the point 0, negative 2. Find the values of the 6 trig functions of theta. So since this point is 0, negative 2, it's straight down. That means it's a 270 degree or a 3 pi over 2 degree angle. So essentially here, we haven't moved anything in the x direction. We've gone negative 2 in the y direction, and the radius is 2 because it's 2 units from the origin. So using those values, we're going to create a sine theta of -1, cosine of 0. Tangent would be -2 divided by 0, which is undefined. The cosecant would be the reciprocal of -1, which is still -1. Secant is the reciprocal of 0, which is undefined. And the cotangent is the reciprocal of -2 over 0, so 0 over -2, which is just 0. Okay, check your progress problem on this. We're going to do another quadrantal angle at the point 3, 0. And they want to know which of the following trig function values of theta is incorrect. So some of these are correct and one of them is incorrect. Which one is incorrect? So you're going to need to find all 6 values and then figure out which one of these doesn't match what you found. Again, put this in your classwork page and make sure you select your answer choice. Okay, another key concept on reference angles. So a reference angle is basically an angle that's set between either the positive x or the negative x-axis and your terminal side, and it's basically always an angle that's between 0 and 90 degrees. So if you're in the first quadrant, the reference angle is just the angle that you're dealing with because all the angles in the first quadrant are between 0 and 90 degrees. If you're in the second quadrant, all these angles will be between 90 degrees and 180. So the way you find the reference angle is you do 180 minus your angle if you're in degrees, or you do pi minus your angle if you're in radians. And basically it's going to show you that the reference angle is this piece down here, this small piece. Notice that if you put the regular angle and your reference angle together, you make a straight line, so you make 180 degrees. If you're in quadrant 3, all your angles are between 180 and 270. So to find your reference, you're going to work backwards. You're subtracting your angle to get back to this negative x-axis. So the way you do that is you do your angle minus 180 if you're in degrees, or you do your angle minus pi if you're in radians. And in the fourth quadrant, every angle is between 270 and 360. So we're trying to get back to the positive x-axis. So the way we do that here is we do 360 minus our angle, or we do 2 pi minus our angle if we're in radians. So example 3, we're going to look for how we find a reference angle. So first we're going to sketch 330 degrees and then find the reference angle. So it says because the terminal side of 330 lies in quadrant 4, if we draw 330, that's obviously quadrant 4. We have to use the formula of 360 minus our angle. So we have 360 minus 330, which gives us 30 degrees. So our reference angle is 30 degrees. Part B, negative 5 pi over 6. And then we're going to find the reference angle. So a coterminal angle with negative 5 pi over 6, we could either add 2 pi to this or subtract 2 pi over 2 pi from this. Obviously it's going to make more sense to add 2 pi because that gives us a positive angle, and it's easier to work with positive angles than it is to think about a negative angle. So 2 pi, if we're converting it to something over 6, would be 12 pi over 6. So adding 12 pi to negative 5 pi would give us 7 pi over 6. So 7 pi over 6 is in our third quadrant. So what we're going to do is we're going to subtract pi from that. And 7 pi over 6 minus pi over 6, minus pi, it gives us pi over 6. So our reference angle for this is pi over 6. Okay, check your progress. We're going to have 2 parts, part A and part B. The first one is 315. So they've shown you already what 315 looks like. You just need to find the reference angle. What would this angle be here to get back to the positive x-axis? Okay, part B, negative 3 pi over 4, and then we're going to find the reference angle. So this time they don't show you the sketch. Make sure you draw the sketch yourself of what a negative 3 pi over 4 angle would look like. And then from the choices here, figure out what would be the reference angle for this angle. Okay, another key concept is on evaluating trig functions. In order to do this, it says, first step, we need to find the measure of the reference angle. Step 2, we need to evaluate the trig function for the reference angle. Step 3, determine the sign of the trig function value and use the quadrant in which the terminal side of theta lies, the angle lies. So this is the original angle. So what the concept here that you're thinking about is, if your original angle ends in quadrant 1, obviously everything is positive because x and y values are positive. If your angle ends in quadrant 2, your original angle, then your y's will be positive, but your x's will be negative because we go left, so we're in negative x values, but we're up, so we're positive y values. If you're in quadrant 3, everything's negative. Remember that tan is y divided by x, so when you have a negative over negative, you're going to end up with a positive. And in quadrant 4, we'd have positive x values and negative y values. So sine and cosecant will be negative, cosine and secant will be positive, and tan and cotan, a negative over a positive, will be a negative. This is another super important thing that's going to help you understand trig functions, so make sure you write this down into your notes. All right, example 4, we're going to use a reference angle to find a trig value. We need to find the exact value of sine of 135. So it says because the terminal side of 135 is in quadrant 2, a 135 degree angle ends in quadrant 2, we're going to use the formula of 180 minus 135. That gives us 45 degrees. So our reference angle is 45 degrees. And because we know that a 45 degree angle is sitting on one of those 45, 45, 90 special triangles that we learned back in lesson unit 4, lesson 1, we can use the ratios from that triangle and figure out that sine is going to be square root 2 over 2. So the sine of 45 is root 2 over 2, and because we're in quadrant 2, where y values are positive, sine is the y value, we're still positive. So our final answer is root 2 over 2. Part B, we're going to find the exact value of cotan 7 pi over 3. So first thing we should do is think about the fact that a 7 pi over 3 angle is more than one full circle. If we make one full circle 2 pi rotations, 2 pi is the same as 6 pi over 3. And we obviously have gone one more, because 7 pi is one more. It's 6 pi plus 1 pi. So our reference angle is one more pi over 3 rotation past a full circle. So our reference angle is pi over 3, which is in quadrant 1. So we know that x is going to be positive and y is going to be positive. So a pi over 3 is the same as 60 degrees. So this comes from a 30, 60, 90 triangle. So we need to figure out what's the y side of a 30, 60, 90. If our angle is 60 degrees, what side is opposite 60? And then the radius would be 1. That ratio, when you write it down, will simplify to root 3 over 3. So our answer is root 3 over 3. Okay, we're going to look at check your progress. We need to find the exact value of sine 120 degrees. Make sure you write this down and work it out. And we're going to look at part B. Part B, we need to find the exact value of cotan 11 pi over 2. Again, make sure you write this down in your notes, show your work, and then pick the answer choice from this lesson. We're going to pick up with one final example in the next video.